Good afternoon, everyone. My name is Dustin Chumley. Sorry about yesterday. I know I might potentially go live with yesterday's event with Missouri. Um, I pretty sure I thought I was going to get that one right, but as I saw, I missed it. Um, I'll openly admit I missed that prediction. There was a few tornado warnings from Nebraska. I had a quick glance. Nebraska is probably slash Kansas borderline. Um, Yesterday they had a mesoscale discussion. It was talking about how there was a dry line moving through the region. If you look back on yesterday's video on EWAL, you'll see a big red patch and the relative humidity that would be on the lower right corner. And as that dry line was moving north, the cold front was moving east. And what was happening, these storms, as they were firing, were getting undercutted because of the cold front moving through the region. So I should have seen that. I mispredicted it, but it'll be okay. I felt like if the dry line wasn't moving there and the storms were able to initiate, like some model guidance were showing, I felt like some of them storms could have had a potential. I even said that in the mesoscale discussion that um, if a storm can briefly form because of the modest mixed layer cape and um, nice shear profile, that it was there. It was all there. It was getting undercut because of the eastward moving cold front with a northward moving warm dry line. So it's okay. I should have seen that mispredicted. Um, so next time I'll keep that in mind for my next prediction, whenever that, which is today's event. Um, Probably won't be the same scenario. I haven't quite. Um, we're gonna break this down and we're gonna see what's happening. I'm looking at it with a fresh pair of eyes. It's been I've been really busy lately, so I haven't had a lot of time to look at this stuff. That's the reason why we're just gonna go over this real quick. Anyways, as we can see, there's been a moderate risk issue in Michigan and parts of northern Ohio. We can see an enhanced risk that goes Michigan, Illinois, Ohio, and a slight risk that extends over a large region. Right here, we can see a marginal risk that extends all the way down. There's going to be if I remember from yesterday's models, there's going to be a cold front that would be trailing from the low that's up here. But anyways, let's break it down. We'll see what's happening. Okay, so we can see that almost the whole state of Michigan, parts of Illinois, parts of Kentucky, parts of Ohio is in the 5% chance range for tornadoes. We can see our 2% risk from like large rain like New York, Pennsylvania, West Virginia, Kentucky, Illinois, um, all the way around. So the tornado chance seems to be very low. We will figure out later why this is. But anyways, let's look at the wind event. As we can see, um, the moderate risk must have came out because of this wind event. As we can see, we have a 45% with a SIG, meaning significant chance of wind event happening through Michigan, Ohio, parts of Illinois. 45% in parts of northern Ohio and Michigan and parts very corner of Illinois, and we can see a 30% just I'm at 30%, my bad, that's in Ohio, oh, uh, Michigan, Illinois. We can see a 15% that runs all from New York, Pennsylvania, West Virginia, Kentucky, Ohio, Illinois, and Michigan, and 5% that runs all the way down here to, let's say, southernmost Alabama slash Mississippi to all the way north Michigan. Alright, we'll look at our wind event. As we can see, only a 10% range in areas like Illinois, Michigan, Ohio, Kentucky, West Virginia, Pennsylvania, and New York. And we can see that there's a 5% that runs all the way from South Alabama all the way up to Michigan. Okay, So let's go ahead and let's pull up two websites. We're going to look at eWall, and then this is a Pennsylvania, I'm at Penn State website. I know a lot of people don't like using uh, college websites for radar, but I personally do. To me, they're a lot better, but that's just my opinions. This is what I look at. And anyways, we're going to look at for analysis. As we can see, our occluded front, we have an occluded front with a cold front, and we got another front low boundary. I wonder if that's from the remnants of Cristobola, which it is, as we can see. So we got Cristobola all the way up here with a warm front and a cold front. We got another low down here with it occluded with a trailing cold front. As we can see, we got an outflow boundary in Mississippi by the looks, according to the text. So that's where those storms will initiate. So we will further break this down. Let's look at eWall. We're going to both look at the NAM and GFS really quick. We're going to break it down, see the differences. So as we can see, we got a intensified warp max and over Kansas. We can see that over heat right here, and we got looks like some dry air out in the head of this right now. So kind of dry fronts, kind of something like this. But anyways, as we look, our low is located right here between Missouri, Kansas, Iowa, Nebraska. So if we probably look at radar, there's probably no rain. Well, I could be wrong. Let's have a further look. We're going to look in this region about right in here. But as we can see, there is a wind advisory. As we can see, there's very little rain through this area because there's dry air according to the NAM. Okay, so let's go one step. We can see it becomes occluded. This down here, as we can see, this low up here in Michigan is starting to turn. The remnants of Cristobola is starting to like a shortwave trough. So we can see that. Okay, 18 frame 18. We can see our low strengthen up here. Okay, 24. This low comes up, the secondary low, and this other shortwave trough is moving through. It looks like it might be negative tilt a little bit. This can help with convergence and diffluence and all that. But then we'll get into that later. But as we can see, this is when the precipitation is starting to form. So this is about 00Z. So it'll be 7 o'clock my time. Okay. So we got no evidence of dry air. It looks like as the system was moving through, it became the relative humidity. That means probably moisture moving through the region. As we can see later that evening, everything becomes linear, with still a negative tilt trough, long wave trough right here. So it looks like maybe 0Z, if there is any chance for tornadoes to form today, maybe 0Z is the best time because these are when the storms are initiating before they become linear. So there's great height falls through this region. With this great height falls, the reason why I know that is because of this vorticity. Anytime you have vorticity maximum through the region, it causes height falls. Because this is like, imagine it's like a big blob of cold air and warm air, and it helps create height falls. It is what it is. It is what it is. Anyways, so now let's look at our winds. We can probably suspect a pretty good jet to come around base of the system. So here we are here. So as we can see, we got about 00Z. The jet maxima is coming around the base. And what we have this time compared to yesterday's event, our upper level winds did come around the base of the trough, and they will be in place. As we can see on this are on our lower winds that on the eastern side of Michigan we can see a lot, and parts of Illinois and parts of Ohio, that there is going to be some stronger um winds, low level winds through this area, also with some mid level winds strengthening. This is when that system's starting to become negative tilt, as we can see. So you can see that strong um, mid level and low level and modest upper level winds. So we could. This is definitely the time when those storms are going to initiate. These strong winds will help with updraft. So we can definitely see that happening through time. Okay. And this is all because of that low that's over here in Nebraska, Kansas, Missouri. We're waiting on it to shoot up. Okay. Now, look at our front. So like I said, looks like we got a trailing cold front through this region with also this other low here. It looks like the system comes occluded a little bit. You know, they don't really necessarily draw it, but yeah, this is when that lower winds and upper comes around the base of the system right here. So as we can see, these are when the storms are pushing through. Alright, so next we'll further break this down. First thing I guess we're going to do is we're going to look at the HRRR. We're going to have a pretty good idea. So it looks like these are when the storms are going to fire up. As we can see, it kind of looks linear already, about 19Z, 20Z. So we can definitely suspect, but we can also see that there's going to be cellular storms that are down here in Ohio. That's going to be very interesting. Let's go back a few frames. These are when the storms down here to the south of this looks like I can't say, yeah, a quasi-linear system. These cells down here might have the potential of becoming tornado. One, because they're by themselves or more cellular than these storms up here. But of course, within any linear system, you can always have quick, brief spin up tornadoes. And like I said, I don't think there's going to be a dry line for now on. After I learned that about yesterday's event, so we can see there's a looks to be like no, but it's ahead. There's a dry slot right in here, but it's ahead of the storms. And we didn't even look at the GFS. Let's see if it's depicted. So we can see a huge vortex through this region. Here's our low, where it is right now. See if it does the same thing. So we can see it becomes negative tilt. It depicts the vortex being a little stronger. So even greater height falls will probably occur. So about right in here, these are when those storms should initiate. Trough is negative tilt, so we'll have greater convergence and divergence to this region. And definitely keep your eyes on the Ohio region. Ohio is looking really promising for maybe a better chance for tornadoes and all that to occur. So I'm definitely going to keep my eyes on this Ohio, this southern Michigan slash Ohio slash a little bit of Indiana region looks really promising. Definitely when these southern cluster down here forms. So definitely something to keep an eye out. We'll look at updraftility and all that later. First, let's look at the RAP analysis and see what it shows. Oops. How do I keep doing that? Okay. Okay. So here we come. about 19Z, so we can see these storms starting to initiate. It looks like the wrap has it going a little faster, about 18Z's when it's got it coming through. 19Z and 20Z. So if we compare that to the HRRR, I think it has it coming through a little faster. 17, 18, maybe about the same time. So it looks like about like 3 o'clock or so. Anyways, so we know that we're going to have a great amount of low level winds, mid level, and upper level winds to this region. As we click ahead of this potential QLCS to form, so we can see that our LCL heights are relatively low. Our surface 1 kilometer SRH is pretty okay. But everything else looks pretty good. So we can see the curvature of the photograph. The low level winds reach up to about, let's say 25 knots, relatively speaking. Well, I bet you if we click down here in Ohio, it'll look a lot better. Taking its sweet time. Okay, so it just shows severe. As we can see, the SRH ain't really that great through here. That's very interesting. I was expecting quite the opposite. But this is only the wrap, so we'll continue looking. But as we can see, our mixed-layer cape's up to 1,000 surface cape. So once all of that's being mixed, we only get 1,000 joules of cape to this area. And effective shear only 30. Okay. How about lower? A weak tornado. As we can see, our lapse rates have been pretty decent the last couple scans. Even in Michigan, they look about the same, so we could probably suspect tell that's where that 15% came from. Alright, so let's now further investigate by what's using our surface-based cape. We'll see how much cape we'll have by this afternoon. So as we can see, all of this is going to be unstable through this region. So we don't have to worry about any convective inhibition by the looks of it. Oh yeah, this is the model that doesn't show. But we can see our mix layer does get pretty high. So now we're going to look at our helicity. So usually when there's a low, maybe right in this region might be the greatest helicity, maybe down here, making me double think. So as we can see right here, 18. So we can have a few pockets of pretty modest low level helicity. Let's look at our upper helicity. And notice that the photograph looked fairly straight. Fairly, like I said. So there's not a whole lot of turning, so that's the reason why this system is becoming linear, because when you have winds stacking of one direction, usually, that's when QLCS is formed. But when we have a lot of turning in the atmosphere, usually sometimes QLCS really don't form. But yeah, the Ohio region through this time, according to the wrap, will definitely have a lot more 3-kilometer helicity. So if we look at our energy helicity, I mean, regardless if this is not a tornado event, there's definitely going to be a major wind event that's going to go through Michigan today. Then we can see our EHI. It's pretty good. I mean, we can see it. Very big plumes through the Ohio and parts of the Indianapolis region when these storms first initiate. So when these storms first initiate, there is a chance of them um, probably quickly going to produce a tornado if it happens. So now let's look at the NAM. So it shows the same thing. The storms initiate and it becomes very linear very quickly. So now if we look up, we'll see what it does with the surface-based cape. So everything is pretty much unstable. If we look at our mix, so we're going to mix everything. As we can see, huge plumes of mixed layer cape that with no convective inhibition through this area. Before we look at our SCT, let's also have a look at dew points. So we can see huge plumes of dew points through this region. Okay. We'll see what the third the NAM does with the helicity. As we can see, the NAM shows a whole lot more helicity through this region than the RAP does. Let's look at our 1 kilometer, see what it does with it. So it shows about the same as the RAP. Very modest rotation. I guess now we can look at our SQT, even though we haven't looked. So we can see LCL heights are pretty okay. They're low. LSC heights pretty good. As we can see, the only limiting factor that we can see down here in Ohio is there's not as much surface 1 kilometer winds with these storms, but you know. But if we go next slide, everything seems very linear, but as we can see through the evening, it looks like the chances do go up. We can see a lot more curvature in the photograph as the evening continue. So, that is from the 1 to 3 kilometers. Okay. So let's see what the NAM does with our winds would be causing that. So we can see the winds do shift when the base comes around. We can see our winds turn from the south. We can see them turn a little bit more in the upper levels as the jet is coming around the base of the storm. Increase, so that would definitely help. Look at the so the interesting though, NAM is not showing a lot of energy helicity as the RAP. Nowhere close to as much energy helicity, suggesting that it's even lower down here in Kentucky, the better plumes. So we'll look at that. Margin risk, we can see we got a nice curvature in the lower winds, but the upper levels just not there. So very interesting of the NAM to do this. It just shows no severe, no upper level winds. It's all in the lower levels. So very interesting for sure. Okay. I don't use this model very often. So it shows the same thing. line development. So now we'll continue looking at the HRRR. We're gonna look at you know what? I didn't even on the wrap nor the I have a feeling I know where the greatest chance. Probably the supercell composite would be like something like this through this region right in here. But we'll have a look. We'll have a look. Like I said, like right through that region right in here. It suggests even lower down in here, which makes sense because that's when that we saw that yellow or the strongest jet comes around and it kind of turns a little bit this way. If we look at our SCP, so definitely keeping our eyes in Michigan. Looks like this mid-region Ohio definitely has a chance. Then if we look at the NAM, I don't think the NAM's going to be as crazy with the SCP because the energy felicity is not as high, but I could be wrong. We'll see what it does. Okay, so it just shows a bunch of orange. So it suggests as it continues eastward that the chances will increase, even though the system looks to become more linear. So what you have to look for is little divots in the line. Look at this. See, it's only a green, so and as we can see, it kind of increases as it moves eastward. Okay, so now we're going to see what the HRRR think. First, we're going to look at updraft helicity. We're going to have a better understanding what these storms are going to do, so we can see a bunch of updraft helicities coming through the Michigan area, and we can see some spots down here in Ohio. We can see a pretty good feedback down here. That's going to happen definitely in this corner. This is one of the regions I was looking at, this corner and this mid region of Ohio, and definitely when these storms first initiate. Let's see what it does with the supercell composite. So we can see there's several spots um, down this line. There could be a chance. And we can see the several spots down the line. So overall, this system's going to be interesting to watch. Yesterday, I mispredicted slightly. I did call the northwest portion of Missouri, Kansas, a little bit, but I really did miss it. I didn't um, see that. I should have looked at the dry line better than the cold front, and I should have known it was going to undercut. But learn something new next time to pay attention to. But not. I'll definitely be watching this region of Michigan. Almost whole state of Michigan, I might as well say. I mean, there's a chance. In the Ohio, I'll say this upper corner, so the southern corner, definitely in this region right here, and definitely say mid Ohio. So pretty much like if I was to draw a circle, it would be like right in this region, right in here. It's my main concern for this afternoon. But I'll try to go live this afternoon, but no guarantees. So um, life's been pretty crazy over here. But so everyone keep definitely keep an eye if you're in the Michigan / Ohio / parts of the Indianapolis area, there's definitely is a chance of pre-spin up tornadoes to happen again. Maybe a chance of one long track, maybe. Um, Tornado could happen. But until then, Central Ohio, in this corner, Michigan is my watch area. So through this region right here for tornadoes, for wind, it's definitely Michigan, all out Michigan. So overall, these are my thoughts. This is what I think is going to happen today. I could be wrong. I'll try to go live later this afternoon. Until then, everyone have a good day and keep your eyes on the sky.